Question number 1 is asking us to solve the inequality. Both are absolute signs on both sides. So we note that a parent function of absolute has a graph like this. Similarly, the graph of a quadratic is like this. So they are comparable. Both of them have a vertex. Both of them have same kind of range and domain. So we can convert an absolute function or equation into a quadratic. And what I mean is this. If this is the inequality, okay, I can square both sides and make them quadratic, because inside absolute sign, whether it's positive or negative number, we don't know. But when we square of any number is positive, so we are sure about this. So now we can write them like this, and they become quadratic inequality now, and we can solve them. So we'll have to expand this one first. So 4 multiplied by x minus 3 whole square. When we expand this, it will be x squared plus 9 minus 6x greater than, let me expand this one as well, 9x squared plus 1 plus 6x. So now we will combine both the parts onto the left side. So let me open this bracket while doing so. 4x squared plus 36 minus 24x is greater than, not, okay, I have to bring it to the left side, minus 9x squared minus 1 minus 6x is greater than 0. Okay, so now 4x squared minus 9x squared is minus 5x squared, minus 24x minus 6x will be minus 30x, 36 minus 1 is 35 plus 35 greater than 0. So it becomes a quadratic. Let me divide whole of it by negative 5 so that the leading coefficient becomes positive. And all of them can be divided by 5. So that's why I chose 5. So it becomes x squared positive plus 6x minus 7 less than 0 now. Because whenever we divide by a negative number, we have to change the sign. Okay. And now this becomes, and I can simply factor this now, x plus 7, x minus 1 is less than 0. You can use your calculator to find the roots. This will give us a root, x equal to minus 7, x equal to 1. These are the roots. But we have not solved the inequality yet. So what should we do? We should draw a number line to find the solution and mark these two roots on that number line, minus 7 and 1. Now choose a number less than minus 7 and substitute in, okay, in this one. Okay, if it comes less than 0, which is negative, then that is our answer. If it does not, that is not our answer. So let me choose a number, say minus 10. I'm choosing here minus 10. So minus 10, let me do it here, minus 10 plus 7 minus 10 minus 1, is it less than 0? Let's see. Minus 3, yeah, minus 11 is less than 0. Positive 33 is not less than 0. So this is a wrong statement. This is not our answer. Let's choose a number between minus 7 and 1. I think 0 is a good choice, so I will put 0. Let me do it mentally. 0 plus 7, 7. 0 minus 1, minus 1. 7 times minus 1 is minus 7, which is, yes, less than 0. This is our answer. And obviously, if we take a number more than 1, it will be not an answer. You can choose any number yourself, more than 1. Okay? And it will be definitely a positive number. So our answer is this area from minus 7 to 1. Finally, what will we write the answer? Minus 7 is less than x is less than 1. Please do not write equal sign here because original one does not have an equal sign. This is the final answer. Question 2 is about logarithm. They're asking us to solve the equation. Nothing can be simpler than this. So whenever we have natural log lens on two sides, try to combine them by bringing on one side. So ln 1 plus x square minus 2 ln x is equal to 1. So 1 remains on the right side, but ln came to the left side. Now we want to combine this ln and this ln, but this 2 will stop us. We can't combine them without removing this 2. So let's remove this 2 by doing what? By making this exponent of the content of the ln, x squared. This 2 goes and becomes the exponent of x. Alright, so now we can combine them. It becomes ln, and since they are subtracting, two logs are subtracting, their contents divide. So 1 plus x square over x square, that's how they're combined, equal to 1. Now we have to get rid of ln. So when we get rid of ln from one side, the other side becomes the exponent of the base. What is the base of ln? Ln is same as log base e. So it will become e to the power 1 on the right side. So let me finish it here. We will cross multiply here. So 1 plus x square equal to e x square. Okay, e to the power 1 is just e. Now let's combine x square to find the values of x. So x square stays here, minus e x square comes here, and 1 goes to the other side. Now we'll take x square common from both. We'll be left with 1 minus e equal to minus 1. X square will cross multiply by dividing it by the other side, or if you want, we can do this way. Divide this side by 1 minus c, divide this also by 1 minus c, so that 1 minus c cancels here. So x square is equal to, now there is a negative here. To find x, we'll have to square root, and square rooting a negative looks odd. So let's do what? Let's change the sign of all of them. How? Multiply the up by minus 1, multiply denominator also by minus 1, so that makes no difference. So it will become positive 1 divided by e minus 1. They exchange their places. E becomes positive, 1 became negative. And now we can square root easily. It is not wrong to square root a negative 1, right? Because e may have a negative value, and that's why it will be a positive again, but it looks good when something is positive on numerator. So square root x equal to plus or minus 1 over e minus 1. Okay, now one of them, especially the minus 1, may not work. So let's see, did you have, yes, we have ln x here. Can you see here? So ln of minus square root 1 over e minus 1 will not work, because this will be a positive number for sure. This negative will make a ln of a negative, which is not possible. That means we have to ignore the negative part, so inadmissible. Only answer will be x equal to positive 1 over e minus 1. And since they are saying that we have to show answer in decimals, 3 significant figures, so exact answer is not needed. So we will convert this to decimals. If I put this in my calculator, I got 0.7628. Let's make it 3. In question 3, we have to solve this straightforward equation. That means we have to find the value of theta. Only challenge will be that this is a compound angle that we have to expand. So cos theta plus 60 degrees equal to 2 sine theta. Let's open this compound angle. So it will be cos theta cos 60 minus sine theta sine 60 equal to 2 sine theta. Let's write the values of sine 60 and cos 60. Okay, cos 60 is half, so half cos theta. minus sine 60 will be square root 3 over 2 sine theta equal to 2 sine theta. Okay, whenever we have just sine theta and cos theta and no constant with them, we should convert the whole thing into tan theta. How can we convert it into tan theta? Divide the whole equation by cos theta. So here as well, here. Alright, cos and cos will cancel here, so we are left with just half minus square root 3 over 2 sine over cos tan theta equal to sine over cos again tan theta. We can combine these two now. So let's bring this to the right side. So half equal to 2 tan theta plus square root 3 over 2 tan theta. Okay, let's add this because both of them are tan theta, so we can add 2 and square root 3. So half equal to 2 plus square root 3 over 2 tan theta, and divide both sides by 2 plus square root 3 over 2 and 2 plus square root 3 over 2. Don't worry, it looks so complicated, but don't worry, as long as you keep your cool and you write the fractions properly, there will not be any problem. So because these days calculators do everything, so theta will be equal to tan inverse. If you want to convert half into 0.5, that's fine, no problem. Yeah, it will be easy to put in our calculators. Square root 3 over 2, done. And this whole thing is positive. This is positive, this is positive, this is positive. That means our angle will be in positive quadrant, and for tan theta, it will be here and here. In these two quadrants, our answer should be, and look here, they are saying from 0 to 360. That makes perfect sense. So we can find the angle now by using a calculator. And by the time I find the angle, please subscribe to this channel. I will make such quality videos in future too. And I got the answer 9.89. So one decimal place, it will be 9.9 degrees. So 9.9 degrees in this quadrant and 9.9 degrees in this quadrant with horizontal line only. Never make this angle with vertical here, never. So the first answer, theta 1 will be in the first quadrant, which is 9.9 degrees itself. Second answer will be this one. Let me show you from here. 0, 90, 180 plus 9.9. So it will be 180 plus 9.9, 189.9 degrees. These are two answers. Question 4 is about improving numerical solutions. We can see iterative formula here. We can see some xn plus 1, all this. So they're saying in first part, by sketching the suitable graphs, show that the equation this is equal to this has only one root, and from 0 to half pi. So they have already given us the interval, right? Since you are going to university very pretty soon, so I recommend that you should know the parent functions of like quadratic and quad. So this thing becomes fast because just 2 marks are there. That's what I will do. If you have no idea how the parent graphs look like, do one thing, make a table for each one for x, y, and in next part they have given us a hint. The answer is between 0.6 to 1, and they have also given us a domain luckily. So you should choose numbers between 0 and half pi. Half pi is same as 1.57. So you can make 0.2, yeah, 0.2, 0.4, 0.6 and up to 1.6 because 1.57 is less than 1.6. So, and then you can put x values one by one and you'll get graphs, but that will consume a lot of time. So what should you do? You should know the parent functions. Let me show you how knowing parent function helps. So this is my graph area. I will focus on only the parent function x square, and I know that x square looks like this, a parabola, right? What will 4 do? 4 will compress. It will make the graph very lean. So which was wide becomes very lean like this. Okay? Because of -1, it will go down by 1. So whole of the graph will go down by 1. So let me first draw that one and then I will show you how. So something like this. So which was at 0, the vertex was at 0, now vertex will be at -1. So let me draw it better way. Okay, I did it step by step because I want to show you how it looks like. So the graph, let me make it a little wider because I'll make my scale accordingly. So this is the graph of 4x square minus 1. This is -1. Okay, they want an answer between 0.6 and 1. So let me write here 1 here, somewhere here. Okay, 1 and then 2 and then 3. Now we have to focus on cortex. Cortex graph parent function looks like this. It's always a decreasing graph and it does not pass through the 0, 0. So it will be like something like this. Something like this. The y-axis is an asymptote and our graph will be going, pi by 2 will be somewhere here. Pi by 2 is 1.57, right? So our graph for cot will be decreasing, coming like this. So it will not cross this graph on negative side. So other one, 1.57 will be somewhere here positive, pi by 2. So the graph will go like this and something like this. So we can see it is crossing it at this point and this point is between 0.6 and 1. We can see that. So there is no need to draw the graph which is on the negative side, but for the sake of explanation, I did that so that you understand how it looks like. So I deleted the negative part. Let's go to the second part of this. Verify by calculation that this root lies between 0.6 and 1. And for that, what do? We have done this earlier also in some videos. We put everything on the left side. So 4x square minus 1 was equal to cortex. We'll bring the cortex also as well to the left side. Equal to 0, right? That's the equation. But what will we do? We will substitute 0.6 and 0.6 and 1 by 1 here. So when x is 0.6 and then when x is 1, this is second part of the question. So it will become 0.6 square minus 1 minus cot 0.6, and I will not write equal to 0 because it will not be equal to 0. The root is between 0.6 and 1. It is not the root, so it can't be equal to 0. So we'll evaluate it equal to what? Similarly, we'll do here 1 square minus 1 minus cot 1. Change your calculator to radians and evaluate both of them. So I got minus 1.02 here and positive 2.36 here. One challenge I faced was that there is no cot in our calculator. So in place of this cot 1, I wrote 1 over tan 1 because cot is reciprocal of tan. So once I did that, these two answers I got. And now we can see that this is negative, this is positive. That means there will be 0 somewhere in between. And that shows that the root is present between these two numbers, 0.6 and 1. So we'll write the change in sign shows the presence of the root. Let's move on to part 3, which says use the iterative formula this to determine the root up to 2 decimal places. Give the result of each iteration in 4 decimal places. So let me copy this one and restart the whole question again. So here it is. Since the answer is between 0.6 and 1, we'll start with 0.8. So let's write x1 equal to 0.8. So according to the iterative formula, x1 plus 1, which is x2, will be equal to half square root 1 plus quart 0.8. In place of this, let me write 1 over 10. It will become easier. Okay, so I will evaluate this and that will give me x2 and then I'll substitute it back. So let me do it one by one. So I got this one as 0.7020 and this is what I will use in x3 now and repeat the process. Let me fasten the process. So now you can see that I went up to x6. Why? Because if I round off them up to 2 decimal places, which they are asking in the question. If you go back to the question and see, they're saying every iteration should be 4 decimal places and the correct to the 2 decimal places should be the root. So when I round off them, this is 70, this is 74, this will be 72, this is 73, and this is also 73. Whenever they become equal, we stop. So the root is 0.73 because here it is stabilizing. In question 5, we have an integration here to be carried out, but before that, using substitution x equal to 2 sine theta, we have to convert that integration into this format. Okay, so x equal to 2 sine theta. So we have to substitute not only x, we have to substitute dx also. So let's differentiate this and we'll get that also. So differentiating this with respect to theta will be 2 cos theta. We can also write this as dx is same as 2 cos theta d theta. So after substitution, it will be 2 sine theta. X is 2 sine theta, right? This one squared divided by square root 4 minus again 2 sine theta square and dx. We got dx also 2 cos theta d theta. There is a problem. We have not converted this 1 and 0. So let's do that also here. So when x is 0, this one is for x, right? This 0 is for x. So when x is 0, according to this, what happens? 0 equal to 2 sine theta and divide both sides by 2. So 0 equal to sine theta. Theta equal to sine inverse 0. And the smallest value for that is 0. Theta is sine inverse 0 will be 0. So this 0 is 0 for theta as well. Let's do the same thing for 1. So 1 equal to 2 sine theta. So divide both sides by 2. Sine theta is half. So theta is sine inverse half. And sine inverse half is 1 over 6 pi. So we got our limits also. So it will be 1 over 6 pi, which matches with our target 0 and 1 over 6 pi. Alright, let's carry out rest of the calculations. So 1 over 6 pi 0, this becomes 4 sine square theta, and here it becomes 4 minus 4 sine square theta multiplied by 2 cos theta d theta. So if I look at my target here, it is 4 sine square theta, which is already there. So I'm not multiplying this 4 and this 2 for the time being. because I expect this to go. So let's continue. 1 over 6 pi 0 4 sine square theta. In these two, let's take 4 common. 1 minus sine square theta, 2 cos theta d theta. Okay, so it becomes 1 over 6 pi 0 4 sine square theta again, and square root of 4, and 1 minus sine square theta is cos square theta, times 2 cos theta d theta. Okay, 1 over 6 pi 0 4 sine square theta, and now we will square root 4, it becomes 2. Square root cos square, it becomes cos theta, and that's why I didn't touch it. I was expecting them to cancel out, and they are cancelling out. 2 and 2, cos theta and cos theta gone. We are left with 1 over 6 pi from 0 4 sine square theta d theta, and that's what the target was. That's what it is, I. Hence, find the exact value of I. Now we have to integrate it and find its value. Okay, whenever we have sine square, first of all, separate 4 from it. Sine square theta d theta. I will apply 1 over 6 pi and 0 later. Let's focus on this. Whenever we have sine square theta, use this one. Cos 2 theta equal to 1 minus 2 sine square theta. This identity will be useful here. Sine square can convert into a non-square trigonometric ratio. So let's bring this here and bring cos 2 theta to the right side. So 2 sine square theta equal to 1 minus cos 2 theta. Both sides divided by 2. So sine square theta is 1 minus cos 2 theta, and sine square theta is here, and we will substitute. 4, and then we have here 1 minus cos 2 theta over 2 d theta. This 2 and this 4 will cancel, and we have a simple integration now. Now the integration will be, okay, 1. For 1, integration will be theta minus cos 2 theta. It will be sine 2 theta over 2 and plus c, from 0 to pi by 6. Okay, so now we can substitute pi by 6 and 0 1 by 1. So 2 theta is pi by 6 minus sine 2 pi by 6 over 2 plus c minus 0 minus sine 2 times 0 over 2 plus c. So now c and c we can cancel out, right? 2 times pi by 6 will be pi by 3, and minus this 2 and this 2 will get cancelled out, so we'll be left with only this, and 2 and 6 can also cancel out. So this 2 will get cancelled out with this 2, so we'll ignore it. Sine pi by 3 will be square root 3 over 2 minus, this is 0 already, sine 0, the 2 times 0 will be 0, sine 0 is 0, so 0 divided by 2 is 0, so nothing after that. Okay, we can undo everything. There will be nothing after what we get here. That is the final answer. Here they have given a complex number z, which is defined as square root 3 plus I. They're saying find the modulus and argument of z. So we know the straightforward shortcut, but let's try to visualize this. Square root 3 is the real part. So 1, 2, 3. Square root 3 will be around here. This is square root 3, and I. Imaginary part is positive 1. This is imaginary, this is real. So this will be the complex number z. Now we have to find its modulus. So modulus is its distance from the origin, and it is found by, let's write, modulus of z is square root of square of the real part plus square of the imaginary part, and that to the coefficient only. Okay, so it will be square root 3 and square will cancel out, 3 plus 1, which is square root 4. And since it's a distance modulus, we can't try negative, just 2 is the answer. That is the modulus. Now argument is this angle. How much is this angle? Let's call it theta. So tan theta will be 1, which is this height, 1 over adjacent, which is this line, which is square root 3. So theta is tan inverse 1 over square root 3, which is pi over 6 or 30 degrees. I'll use radians. Second part. The complex conjugate of z is denoted by z star. Okay, showing your working. Express this in x plus iy form. X and y are real. So let's focus on 2z plus z prime first. So let me write here only. 2 times z. Z is square root 3 plus I. Plus z prime is square root 3 minus I. So let's open the brackets. 2 square root 3 plus 2i plus square root 3 minus I. And this comes out to be 2 square root 3 plus square root 3 will be 3 square root 3. 2i minus I will be plus I, and that's the answer of first part. Let's do B part of the same. I z conjugate. So z conjugate is square root 3 minus I divided by z, which is square root 3 plus I. So we already know that it's a rational, and we want this format, x plus iy. That means we have to multiply this by conjugate. Square root 3 minus I divided by square root 3 minus I, conjugate of the denominator, not numerator, denominator. And that will be, this is x, a plus b, a minus b format. So their multiplication will be square of a minus square of b. Here I is I, so I'll just multiply because they are exactly same. It will be the square of square root 3 minus I. So a minus b whole square. Let me remind you, if you want, it is a square plus b square minus 2ab. So we'll write a square, square root 3 square plus b square, I square, minus 2 times square root 3 times I. Alright, so let's go ahead. This is square root and square cancel out, so it becomes 3 minus, and I square is minus 1, so it becomes plus 1. So this minus and this is minus 1, so minus and minus 1 becomes positive 1. Alright, we rationalize the denominator. Let's multiply this I with each one now. First of all, this will cancel out, so we'll be left with 3i. I square is minus 1, so minus 1 times I is minus I. Next is minus 2 times square root 3 times I. So this I times this I will be minus 1, and multiplied by 2 square root 3 will be positive 2 square root 3. Let's see what simplified form do we get. 3i minus I is 2i plus 2 square root 3 divided by 4. And we can simplify this by taking 2 common out of this. So I plus square root 3 over 4. And the purpose was to cancel this. Finally, if you want to write, it can be half I plus square root 3 over 2. This is I z star over z in format x and y are real. Done that. Third one, on an argument diagram with the origin O, show that the points A and B represent the complex number Z and IZ. Prove that angle AOB is 1 over 6 pi. So let's try to visualize them first. Okay, so complex number Z first. So Z was, let me write again, Z was square root 3 plus I. So square root 3 plus I, let's say this is square root 3 and this is 1, so this is A. This will be the argument of Z. Okay, now B is IZ, so I Z star rather, so it will be square root 3 minus I, that is IZ star. So it becomes square root 3I, and I times I is minus 1, and this minus will make it positive. So real part is 1, imaginary part is square root 3. So let's say imaginary, this is 1, and this is square root 3 somewhere here, imaginary part. So it will be here, B. And this is the argument of, from here till here is argument of I Z prime. Okay, so they are asking us to prove AOB. So let me show you what is AOB in this case. This is O, this is A, this is B. So this difference between the two. Okay, so they mean that the argument of IZ prime minus argument of Z is pi by 6. This is what they are trying to prove. Okay, we have to prove, not show. So let's use the identity. This will be equal to argument of IZ star over Z. Yeah, and argument IZ star over Z. We already have it. See, B part was IZ star over Z, and we got that as this, half I plus square root 3 over 2. That's what we'll use now. So what is the argument of this? It will be tan inverse the imaginary coefficient, which is half, divided by coefficient or the number of real parts, square root 3 over 2. 2 and 2 cancel. It comes out to be tan inverse 1 over square root 3. And tan inverse 1 over square root 3 is 1 over 6 pi. Proven. Question number 7. With respect to origin, points A and B have these position vectors. The point P lies on AB and OP is perpendicular to AB. So let's draw them. Let's have an idea. It may not be accurate because it's a three-dimensional drawing, but still we'll try to do it. So let's say this is OA. This is OA. This is OB, and this is AB, and P is perpendicular on AB. So I have made it simple. It may not be this simple, but just to show you, okay? So this one is A, this is B, this is P, this is O. All right, find the vector equation of AB. So for a vector equation, we need a point. So let's use the point A. Since it's a position vector, we can use the vector itself as the coordinates of the point. So I'm using 1, 2, and 2. So this is R equal to, point is 1, 2, 2. Then we need a parameter, let's call it A, and then we need a vector AB, right? That's what they're saying. Equation of the line AB. So AB should be the one. So let me write vector AB somewhere here, which will be OB the head minus the tail. They have given algebraic format in IJK format, but I'm using column notation. Doesn't matter which one you use. So I'm using column notation. So OB first. OB is this one, 3I plus 4J. So 3, 4, but there is no K, so I'll write 0. Minus 1, 2, 2, which is 3 minus 1, 2, 4 minus 2, 2, and next one is 0 minus 2, minus 2. That will be the vector we will use here. This is the vector equation of the line AB, where we have written a point and a vector with a perimeter. Find the position vector of P. Let's give some coordinates to P in form of some alphabets, and those alphabets I'm choosing PQR. Since point P lies on line AB, and this is the vector equation of AB, that means these coordinates will also satisfy this vector equation. So we can write here PQR equal to 1, 2, 2 plus A 2, 2 minus 2. So it gives us parametric equation P equal to 1 plus 2A, Q equal to 2 plus 2A, and R equal to 2 minus 2A, right? Now, since we know them now, we can also see that line AB and OP are perpendicular to each other. That means vector AB and vector OP, their dot product will be 0. Vector AB is known to us. We just found out this one is vector AB. Let's write it. 2, 2, minus 2. Dot. OP is unknown to us, but we know that the coordinates of the point are equal to the position vector. So we can use PQR as vectors. So PQR will be equal to 0. And now we can multiply 2 with P, 2P plus 2Q minus 2R equal to 0. And we know that PQR, there are 3 different variables, but if we convert them to these parametric equations, they will have just one variable A. Let's substitute. So 2 times 1 plus 2A plus 2 times 2 plus 2A minus 2 times 2 minus 2A will be equal to 0. Alright, so let's do it now. 2 plus 4A plus 4 plus 4A minus 4 plus 4A equal to 0. So 4A plus 4A, 8A plus 4A, 12A. 2 plus 4, 6. Rather, we can cancel these, just 2. Plus 2 equal to 0. So 12A equal to minus 2. A comes out to be minus 2 over 12, which is minus 1 over 6. And now we can substitute minus 1 over 6 in these equations and we get PQR. Let me do that. So it becomes, P becomes equal to 1 plus 2 times minus 1 over 6, which is 2 and 3 can cancel, 2 and 6 rather we can cancel. 1 minus 1/3, which is 2/3. Here 2 plus 2 times minus 1/6, again 2 and 6 cancel. So 2 minus 1/3 will be 5/3. 2 minus 2 times minus 1/6. 2 and 6 cancel, and there is a plus. 2 plus 1/3, which is also 5/3. Rather, 2 plus 1/3, no, 7/3. These are the coordinates of P, and let's go back to the question they asked us. They asked find the position vector of P, and since we know the coordinates now 2/3, 5/3 and 7/3, the same become the position vector. So we can write position vector of P, which is OP, will be 2/3 I plus 5/3 J plus 7/3 K. Third part of the same question talks about the plane, the equation of the plane, which is not part of the curriculum anymore in 2022. But if you're interested in solving it, you can continue watching videos or you can stop here. That's the equation. Find the equation of the plane which contains AB. So, and which is perpendicular to the plane OAB. Okay. Giving your answer in form of this, you have to find the equation of that plane. Okay. So suppose this is the plane AOB, right? But we don't want equation of this plane. We want equation of a plane which is perpendicular. Let me draw perpendicular to this. So this plane can be this plane, which is perpendicular to the existing plane. To write the equation of a plane, which is this plane, which is perpendicular to AOB, we should have A, B, and C first. A, B, C are the vector which is normal vector to the plane, and we know that this vector OP, this P is here. OP, isn't it OP perpendicular to the required plane? This plane we have just shaded, it is perpendicular, right? Look at the drawing again. If this OP is perpendicular to AB and AB is on the plane, that means OP is perpendicular to the plane also, right? So that's what we will do now, which means we can use this vector OP as A, B, and C in this equation. Let's use it. 2 over 3x plus 5 over 3y plus 7 over 3z equal to D. Let's multiply everything by 3 so that we get rid of these 3's. So it will become 2x plus 5y plus 7z equal to 3D. Now we need a point on this particular plane, and A is a point. I've already written that point here. 1, 2, 2 was the point on the plane which will satisfy this equation. Let's use that 1, 2, 2. So 2 times 1, 5 times 2 plus it was 7 over 3, right? It was 7. 7 times 2 equal to 3D. So it will give us the value of D. 2 plus 10 plus 14 equal to 3D, that is 26 equal to 3D, and D comes out to be 26 divided by 3. So the final equation of plane perpendicular to AOB is 2 over 3x plus 5 over 3y plus 7 over 3z equal to 26 over 3. Since all of them have 3 denominator, we can multiply the whole equation by 3. So we are left with 2x plus 5y plus 7z equal to 26. This is the final equation of the plane that is perpendicular to AOB. This plane I'm talking about, this is the plane whose equation is this. Question number 8, they have given a function, rational function to us, and they're asking us to express it in partial fractions. So the degree of denominator is 1 plus 2, 3, and degree of numerator is 1. So degree of numerator is lesser, so we can straight away carry out partial fractions. So let's write the original function first. 3x 1 plus x 1 plus 2x square, and assume it to be equal to a over 1 plus x plus bx plus c over 1 plus 2x square, bx plus c, because the degree here is 2, so we will get 2 parts here. Alright, so 3x, if we find the LCM of the right side, the numerators of the both sides will be like this. 3x a 1 plus 2x square plus bx plus c times 1 plus x. Since the denominators will be same now, so I'm ignoring denominator of both sides. To find a, b and c, let's start with making this part as 0. It is 1 plus x. So let's assume x equal to minus 1 so that this becomes 0. So 3 times minus 1 equal to a 1 plus 2 minus 1 square and plus 0. This whole thing will become 0 because this part will become 0. Okay, so minus 3 equal to a, and how much is this? 1, and this minus 1 square. We'll use bed mass. So square first. Positive 1 times 2 is 2 and 1 plus 2 is 3. So a becomes minus 3 over 3, which is minus 1. We got a. Let's talk about b. We cannot make this one 0 anyhow because square will make it positive, and positive and a positive cannot cancel out. So in that case, what should we do? Let's compare. Compare constants first. So in this equation, there is no constant here. So 0 equal to, there will be a constant here, a times 1, right? Which is a. A times 2x square will not be a constant, so we'll ignore it. Bx times 1 will not be a constant. Bx times x will not be a constant. Only c times 1 will be a constant. So plus c. Everything else will not be a constant, so we can ignore it. So 0 equal to minus 1 plus c, and c becomes 1. To find b, let's compare coefficients of x square. Is there any coefficient of x square here? No. So 0. Only x is there. There is no square, so we'll leave it. Here 2a will be the coefficient of x square because when a multiplies with 2x square, we'll get 2ax square. So 2a will be the coefficient here. Here bx and x will give us x square. So we'll write bx square, which is just b. Nothing of the others will give us x square, so we'll ignore them. So 0 equal to 2 times minus 1 plus b. So b minus 2 equal to 0. So 2 equal to b. So b came out to be 2. So we have a, b, c, all of them with us now. So we can write our final answer. For the simplicity's sake, I'm writing here. So since a is a negative one, I will write it later. B is positive. Yeah, 2. So 2 and c is 1. So I'll write this one first. This one. So 2x plus 1 over 1 plus 2x squared minus 1 over 1 plus x. Because a was negative, I wrote it this way. This is the partial fraction. Move on to the b part, which is hence obtain the expansion of fx in ascending order of x up to x cube. So first let me copy the final answer. So I have copied the solution of the first part and how we will carry out the expansion. The formula I've written here. Okay, let me rearrange this one. I can write this as 2x plus 1 to the power 1 plus 2x square power minus 1 minus, there's no need to write 1. If you want to write, it's okay, but I'm not writing it. 1 plus x to the power minus 1. So this rearranged as this. And now if we look at this formula, it is 1 plus something. This x is not fixed. Here it is okay, but here it is not. So we can apply this formula to this and this. This has positive 1. We have to have here n less than 0, a negative exponent, which is with these two. We'll apply this formula. All right. So first 2x plus 1 will remain 2x plus 1, but the remaining part will be different because of this formula. So we'll write 1 first, 1 plus n is minus 1 in this case. X is not x, x is 2x square. That's the change here. Because of this x, this is x, but because of 2x square, this part will have 2x square. Next, plus minus 1 times minus 1 minus 1, which will be minus 2. This one will be minus 2 divided by 2 factorial. 2 factorial is just 2, so I will write 2. X square, which is 2x square square, plus n minus 1, n minus 2. So n minus 1, n minus 2 divided by 3 factorial, which is 6. X cube. So 2x square and cube. This is the expansion of the first one. Now we'll write the expansion of the second part. Alright, minus formula is 1 plus nx, which is minus 1x. In this case, x is x, so no need to change anything. Plus minus 1 minus 2 divided by 2 factorial, which is 2 x square, plus minus 1 minus 2 minus 3 divided by 3 factorial and x cube. They said we have to write up to x cube, and that's why I'm writing up to x cube only. I have cancelled these out because they will simplify the things. I have to write, put a bracket here so that this minus affects everything. I have cancelled out these terms as well. Why? Because this will give us x to the power 4, this will give us x to the power 6, which we don't want. We want up to x cube only. So that's why let's make it simpler. 2x plus 1 remains 2x plus 1. Here it will be 1 minus 2x squared. There is no power on that. Only minus 1, so it will make it minus. Okay. Now this one will make it minus 1, and this will be minus 1x, but because of this minus, it will become positive x. 2 I have cancelled already. It will become plus x squared, but because of minus, it will be minus x squared. I have cancelled already this, so it will be minus x cube, but because of this minus, it will become plus x cube. Alright, so let's simplify this. Open the bracket first, so it will be 2x minus 4x cube plus 1 minus 2x square and minus 1 plus x minus x square minus x cube. Plus 1 and minus 1 cancel out. Let's write minus 4x cube, and it was plus x cube, sorry. So minus 3x cube. 2x plus x, 3x. Minus 2x square minus 3x square. Okay, this is already done. We have to write in ascending powers of x. Yes, so it's good because the positive element will come first. 3x minus 3x squared minus 3x cube. That's the answer.
In question 9, the diagram shows the curve y equal to x cube ln x and its minimum point m. We can see that. Find the exact coordinates of m. To find the exact coordinates of m, we should know the x coordinate first, and then we will substitute here in this equation. We'll get the y coordinate. To get the x coordinate, we know it's a turning point, right? Minimum point means it's a stationary point or turning point. That means the gradient at m will be 0. And gradient is nothing but y prime or dy over dx. So let's differentiate this. If y is x cube ln x, dy over dx will be, I will use product rule in this because this and this are multiplying, both have variables. So it will be x cube prime ln x plus x cube ln x prime. So x cube, its differentiation is 3x square, ln x remains ln x, plus x cube remains x cube, but ln x, its differentiation is 1 over x, and this x and this will cancel, so we'll be left with 2 here. Okay, can I take x square common in both, because this is x square, this is x square now, so we'll be left here with 3 ln x plus this out, nothing left, only 1. This is dy over dx, which has to be equal to 0 for stationary point. And if this is the equation, it gives us two answers. X square is equal to 0 or 3, this one, ln x plus 1 equal to 0. This gives us x equal to 0. That's a turning point, and we can see here at 0 it is turning like this. So well done. But we are not interested in this, we are interested in the second one. Let's bring this 3 and make it exponent of ln x. So x cube it will become, and let's take minus 1 to the other side. Okay, now if I want to remove x cube, remove ln rather, x cube will remain alone, so the other side becomes e to the power 1, and to find x's value we will cube root both sides. That means we will give exponent 1 over 3 to the both sides, where 3 and 3 cancel. X is e to the power 1/3. This is the x coordinate of M. What about y coordinate? So we will substitute this in the equation they have given, x cube, that is e to the power 1/3 cube, and then ln x, ln e to the power 1/3. Natural log and e are inverse of each other, they will neutralize each other, so we're left with only 1/3 here, and this will be 1/3 and 1/3 also cancel out, e to the power 1, which is e. So we can write this as e over 3. Question was find the exact coordinates of M. So exact coordinates of M are, we got e to the power 1/3 and e over 3. These are the coordinates. Second part, find the exact area of the shaded region bound by the curve. The x-axis, this is curve, this is x-axis, and line x equal to 2. This basically we have to find the area of, and for that, if I find area under curve from this point to 2, it will be done. So the problem is that we don't know the coordinates of this, but we know that this point is the x-intercept of this curve. So for x-intercept, let's find x-intercept. Y has to be 0 on x-intercept, so we'll write 0 equal to x cube ln x. So it again gives us x cube equal to 0, which is x equal to 0, and we can see that the second x-intercept is 0, so it is of no use. We are interested in second one, ln x equal to 0, and again if I want to remove this ln, x will be e to the power 0, and which is 1. X is equal to 1. So we know the starting point is 1, the ending point is 2, and we can find the area under curve easily now, and I will use this space to do that. To find the area under curve, from 1 to 2 we will integrate the equation of the curve dx, and to integrate this we will have to do integration by parts. So we have one algebraic part here, we have one logarithmic part, and the hierarchy we have LIATE. When we have logarithmic and algebraic parts, this becomes u, this becomes v prime. So log ln x will be u for us, and x cube will be v prime. Now if I write it again, it will be, now x cube is v prime, so u v prime integration is uv minus u prime v, right? We know u, so this u we can write ln x. Do we know v? No, we know v prime. So if v prime is x cube, integrate both sides to get v. So v is x to the power 4 over 4. So multiplied by x to the power 4 over 4 minus u prime. U prime means differentiate this because this is u. So u prime will be differentiation of ln x, which is 1 over x, and then we have just v, and we got v now, x to the power 4 over 4 dx. Okay, let's continue. First part is fixed, ln x. Let's write x to the power 4 first. X to the power 4 ln x over 4 minus this x will cancel with this, so we'll get 1 over 4 x cube. So let's write 1 over 4 outside, and the integration of x cube will be x to the power 4 over 4 again, and then plus c. So they're saying find the exact area. So we got the integration now, we can find the area now. So let's put from 1 to 2 and substitute 1 and 2, 2 and 1 respectively. So let me write here 2 to the power 4 over 4 ln 2 minus, this will be 1 over 16, 2 to the power 4 plus c, minus 1 to the power 4 over 4 ln 1 minus 1 over 16 1 to the power 4 plus c. This c and this c cancels out, that is the first thing we do, and this is 16 divided by 4, 4 ln 2, this is 16, 2 to the power 4 is 16, and this is 16, both cancel out, so we are left with just minus 1. Ln 1 is 0, so the whole thing becomes 0. Do not look at this. This negative and this negative will be positive, 1 over 16, and nothing else is left. So it becomes what? Let's make this 4 as exponent of 2, ln 2 to the power 4 minus 1 plus 1 over 16 will be minus 15 over 16. Okay, what are they saying? Yeah, they're saying exact area, right? So we can't do much. We'll just write the final answer. Ln 16 to the power 4 is 16 minus 15. Let's close it here. 15 over 16. This is the area of the shaded region. After answering this question, I looked at this part. I made a mistake. Minus 1 was here, but I did not write minus 1 here. So this will become e to the power minus 1/3, and similarly, because this is e to the power minus 1/3, so we will have to put minus here and minus here. That's why it will become minus 1/3 here. So this, so the exact coordinates of m are e to the power minus 1/3 and minus e over 3. This is, which I casually did not look because m is below x-axis. This had to be negative, and that's why I needed to correct this one. I apologize for the mistake and inconvenience. Thank you very much for paying attention. Next, question number 10. A certain substance is formed in a chemical reaction. The mass of the substance t seconds after the start of the reaction is x grams. Okay, at any time the rate of formation of the substance is proportional to 20 minus x. Rate of formation means it will increase. So rate of formation means dx over dt is increasing. This is the rate of change. It is directly proportional, right? Is proportional to 20 minus x. Okay. When t is equal to 0, x is equal to 0. So they are giving us this information so that if I convert this into an equation, k 20 minus x, where k is the constant of proportionality, with this we can find the value of k. So let's see it. When t is equal to 0, x is equal to 0, dx over dt is 1. So dx over dt is 1, k 20, and x is 0. So it becomes, k becomes 1 over 20. Yeah. So our equation becomes the differential equation, that is dx over dt is 1 over 20 minus x. Okay, let's see what they are asking us to see. Show that x and t satisfy the differential equation this. And I have already done without looking at the part 1. So this is the solution of part 1, this one. Take x over dt. If you put 1 over 20 in your calculator, it will be 0.05 20 minus x. Done. Find in any form the solution of this differential equation. That means we have to find x in terms of t. That's what they're asking us to do. So this dt will go and become a suffix here. So I will write dx equal to 0.05 20 minus x dt, right? But dt should be with t, not with x. That means this x must move with dx. And how will that move? It will become cross multiplication, it will become denominator there. So 1 over 20 minus x dx is 0.05 dt. Since we have to find a solution of this, so we will just integrate both sides. On the left side we have a reciprocal function. So for integrating that, we just write natural log of 20 minus x, and please keep in mind it is only for linear denominator. If it was not linear, then it would be difficult. After this, we divide it by the differentiation of the contents of the ln, which is 20 minus x, or the denominator here. The differentiation of 20 is 0, so we don't look at it. Minus x, its differentiation is minus 1. That's what we divided this with. Will be equal to negative 0.05 is constant, and integration of dt is t, and we will have plus c. Why negative? This should not be negative. Negative, we'll keep it here, right? So it becomes negative ln 20 minus x equal to 0.05 t plus c. Now to find c, we will use what they have given here, which is t is 0 when x is 0. So when t is 0, x is 0. Let's substitute that one here. Minus ln 20 minus 0, 0.050 plus c. So this is 0, c becomes minus natural log 20. And let's use this c here to get the equation. Minus ln 20 minus x equal to 0.05 t minus ln 20. Let's bring ln 20 to the left side so that ln and ln can club together. So ln 20 minus ln 20 minus x equal to 0.05 t. So if we want to merge these two, they will become one natural log, but since they are subtracting, the contents will divide. Equal to 0.05 t. Now if I want to get rid of ln, just like question number 9, we'll be left with 20 over 20 minus x here, and the right side will become e to power 0.05 t. And they said find find in any form, but let's try to simplify it by isolating x. So x will, this 20 minus x will go here and e will come down, so it will be rearranged like this. 20 divided by e to the power 0.05 t will be equal to 20 minus x. I want to isolate this x, so this x will go to the left side and this whole thing will come to the right side. So our new look equation will be x equal to 20 minus 20 divided by e to the power 0.05 t. This is the format I'm presenting this in. though they gave us liberty to use any form. Part 3. Find x when t is 10, giving your answer one decimal place. So we'll just substitute this t by 10. So x equal to 20 minus 20 divided by e to the power 0.05 and times 10. Just put this in a calculator and you'll get your answer. Let me use my own calculator. By the time I do this, I would request you to click on that thumbs up icon and subscribe to my channel. Only 4% of my viewers have subscribed, 96% just watch and go away. So if you subscribe, that will be awesome and motivate me to make many more videos like this. Okay, what I'm getting here is 7.9, approximately 7.9. Okay, what is the next part? Part 4 says state what happens when t becomes very large. Okay, when t becomes very large means t goes to infinity. X will be 20 minus 20 divided by e to the power 0.05 infinity, right? In place of t, I'm writing infinity now. 0.05 times infinity will be infinity, yeah? A very big number multiplied by 0.05 will be infinity. That means it can become 20 minus 20 over e to the power infinity. And if you see your previous knowledge, e has a value. It is 2.7 something. So if that number has an infinity exponent, what will happen to it? It will be infinity itself. So it will be 20 minus 20 divided by infinity. And 20 is a very small number as compared to infinity. If I divide 20 by a very big number, it will be almost 0. So we'll be left with 20 minus 0, which is 20. So your question was, state what happens to the value of x when t becomes very large. We will write when t becomes very large, x approaches 20 because it is becoming almost 20. This concludes our solution video. If you like this video, please give it a thumbs up and subscribe to my channel. Thank you very much.